All right, now you see a triangle, but you see more than just a triangle, don't you? You see two triangles. You see one here and one here. What we're going to do is we are going to do our first proof. All right. I told Allie up here. I said I had a group of students. It was years ago, and man, it was the one class I remember. They were really into it, especially this one group of girls. And they just, for some reason, they just love geometry. They're now married, and at least a couple of them have kids now, and that kind of thing. So it's been a little while, but they really liked it, and they loved doing proofs. They just loved it. They just thought it was the coolest thing, and they would ask me to do harder proofs, and and that kind of thing. That's not usually the norm, but the norm, yes. And but it can happen. So what I'm telling you is that it can happen. And I've had, I wouldn't say the majority, but I'd say from time to time I got people that really do enjoy these and like doing them. So it's different. It's so different. It's not like regular math. It's completely different. So let's see what we're going to do. Now, you know how we skip chapter 2? We skip chapter 2. Right. We skipped chapter 2, and a lot of stuff in chapter 2 is kind of leading you up to proofs a little bit. So I kind of hate to skip it, but on the other hand, there was a lot of stuff that I thought I could kind of just slide in when we get to this chapter, and that's what I'm going to do every once in a while, okay? Just put a few things in here. So that's what we're going to do. So what we're going to do is we're going to try to prove something. Now, first of all, in a proof, they'll give you some information. Like right here, you don't know anything about this. You know you got two triangles and one big triangle, and that's about all you know. All right, but they don't really tell you anything, but they will. And they always tell you stuff in this little section called the given. They usually put like a, what do you call that, a colon after it or something. And so they'll put a given. So let's do a given here. Let's say, kind of. I changed it a little bit, okay? So I changed it a little bit. So, I don't know. You want to do the one? I'll tell you what. You want to do it exactly like that one? Yeah, we will. All right, I rearranged the picture. I made it look a little different to look like the one in the book. I thought I would go a little bit easier, but I think this might be a little easier, to tell you the truth, this picture right here. So let's go with this one. Let's see what they say. And this is exactly from the example, so you could look right at the example and see what's going on. They tell you that GH, that line segment GH, is congruent to KJ, line segment KJ, right? And oh, it's also congruent to JL. JL. I had JL in class last year, and every once in a while you'd have a JL. I always thought that was funny. I said, JL, you're up there. All right, and L is the midpoint of GK. GK. All right, so that's the given. This is what they're going to prove, or what we're going to prove, hopefully. We want to prove that triangle GHL is congruent to, I'll have to slide this over after I'm done, KJL. KJL. So let's scooch this. Oh, goodness. There we go. So let's move that right there so we can see it. All right. Let's take a look at what they give. So this is the first thing we do on just about every single proof that we're going to do. The given, we're going to try to mark it in our picture so we can see in our picture what was given to us. All right. It says that GH is equal or congruent to KJ. Well, here's GH. So how do I show that these two are congruent to each other? Put a what? Put a little tick mark. Put a little tick mark here, a little tick mark here. And it's also equal to what else? JL. Right there. You with me so far? Now, I do this proof a little different than they do. They have this thing, I don't really, I mean, I kind of get what they're doing, but they say we're going to do a flow proof. I don't really, you know how you do like outlines with your papers and you don't write every single word? You do an outline. That's the flow proof is kind of like an outline of a proof. All right, is basically what that is. All right, so let's see what we're going to do here. And it says L is the midpoint of GK. So watch this. If L is the midpoint of GK, what do you think else what else do you think that I could write in here? That what? Do I want to say G and L? Because you're talking about 2 points. Line segment GL, right, is congruent to what? Line segment LK, right? Everybody see that? And how did we know that? Because L was the what? The midpoint. Now, what tells us, if I know that L is a midpoint, what tells us? Because we have to back up all our reasons, and we're going to go through this. This might take a few days to really get used to this whole proof thing, all right? So you just have to be patient. I'm not expecting to know this all ready, okay? This is all brand new stuff for you. You didn't learn this in Algebra 1. You didn't learn this anywhere else, okay? This is all brand new. But what tells us if point L is the midpoint, that GL and KL are equal to each other? How do you know? How do you know those two segments are equal? Because what? Because L is cut in half. Okay, because L is the midpoint, right? And what does the midpoint say? What does the word midpoint mean? It means that it divides a segment into 2 equal segments. If you wanted to look back at it, you could look back at it, and that's what it says. If you look back at the definition of midpoint, it doesn't really say that it divides a segment into half. What it says is this: a midpoint splits a line segment up into 2 equal segments. All right, that's what a midpoint says. Now, where do you look to find the meaning of a word? In the dictionary. And the dictionary gives you what of the word? The definition, right? So, if I wanted to give a reason why GL and KL were equal to each other, what do you think my reason would be? Because L is the midpoint, but what tells us that L being the midpoint splits it up? The definition of the midpoint tells us that this and this are equal to each other. I can't just say because L is the midpoint. I have to say what that means. Okay, well, who cares if L is a midpoint? Well, we do care because L being the midpoint means, the definition of midpoint means it does what? It splits the segment into what? 2 equal parts. And there's my 2 equal parts right here. Everybody see that? So I will have to give a reason here in a second, but I just wanted to make sure that we understood that. So when they say L is the midpoint, that means that GL and KL are equal to each other. Why? Because of the definition of a midpoint. Everybody see that? And you don't have to write out the definition of the midpoint. All you have to say is definition of the midpoint. Okay? All right. So let's see what we can do here. Yes. I think I'm doing the same exact example, right? Oh, yeah. I missed it, didn't I? I thought I was looking at this, and I was kind of a little bit worried, and I thought I would catch on pretty quick. But thanks for that. Yeah, thanks for that, because let's stick this up here. Yeah, I just kind of saw that HL is equal to JL. Yeah. It does too, actually, because I was a little worried myself. I was fretting, and I was thinking, uh-oh, what does that have to do with that? So this is what it should be. Not those 3 things are equal to each other. GH and JK, so GH and JK are equal to each other, so we were good with that, right? But then it said, and I just didn't see this, I just overlooked this HL, all right? But then it says that HL and JL are equal to each other. So now, does that mean that HL and JL are the same as GH and KJ? No. All right, so I'll tell you what, let's put 3 there since we already put 2 down here. Is that all right? You with me on that? Okay. All right, so we're actually good to go. This is actually very, very simple proof. It does. Why are these 2 triangles? Exactly, you're seeing it, see? There you go. See, now you discovered it. It's side, side, side. Now the triangles are congruent, right? But our proof, well, it's not just one answer. It's a series of steps to get the answer, okay? So what we're going to do is we're going to write down steps. We're kind of like, I mean, it's a proof. Like if you're in the court, all right, and you're a lawyer in the courtroom, and you wanted to prove something was true, what do you have to do? You got to go through a series of things, right? You got to go through all the, what'd you say, Caitlin? Okay, you got to explain it, but you have to go through all the evidence. That's the word I was looking for. Okay, you got to go through all the evidence and lay it all out, right? And it takes them sometimes weeks and weeks, doesn't it, to do a trial? They have to lay it out step by step by step to prove to the jury that the person did it or didn't do it or whatever the case is, okay? And that's kind of what we're doing here. Put yourself in that mindset that we have to go through step by step in order to prove that these two triangles right here are congruent to each other. So this is what we do. We do a thing called a two-column proof. So I'm going to put a line right here, and let's scooch this down a little bit. And then I'm going to put a line right here. All right, and let's make these white instead of red. All right. Now, I got two columns. That's why they call it a two-column proof. Not brain surgery, is it? All right, so this left column is called the statements. So write that on top here. These are the statements. But just like in a courtroom, a lawyer's got to back up what they say. They can't just throw out some outrageous statement without having facts to back them up. Or they're not supposed to, at least, right? So if you have statements, you must back those statements up with reasons. All right? So you got statements and you got reasons. So we're going to list our statements here, and right next to the statement, we're going to list the reason for that statement. You okay with that so far? All right, so what we're going to do is we usually start with the given. You don't always have to, but it's always a good place to at least begin. All right, so what did they tell us? Because we didn't know anything about these sides before they told us all that stuff, right? So what did they tell us at first? They told us that, well, GH and KJ, it doesn't matter what order you go, all right? But you want to do the GH one first? So they told us that GH, line segment GH, was congruent to line segment KJ. Now, what's the reason for that? How do we know that that was true? It was given. They gave it to us. Exactly right. It was given. So all I have to do for my reason is just write given. So those are the easiest ones. When they tell me the information, I always love that because I can just write down for my reason, given. You okay with that? What else did they give us? They gave us, yeah, they gave us HL and JL, didn't they? So HL and JL. All right? And you can write given again if you wanted to, or you could just use the one given to represent both of those. All right? Here's something that I do that you won't see in the book, but I kind of like to do this. This helps me out when I'm doing this. So what did I just find? I just found one side equal to another side, didn't I? Because you guys already did it already. You kind of discovered why those two triangles were congruent already, didn't you? All right, and you saw it. You looked ahead, and that's what we want to do. So GH and KJ were one of my what? One of my sides, right? So what I do, you don't have to do this. They don't teach us in the book, but I kind of like to do this. I like to put a little S next to it so I know that I found one of my sides. I found one side equal to another side, so I put a little S right there. What's this one right here? It's another side, isn't it? It's a different side, agreed? So two different sides. So far I got side and I've got side. Well, I only know so far, up to this lesson, I only know two ways to prove triangles congruent. One is side, 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 and another one is, what was the second one? Side, angle, side, okay? But on this one, do I know anything about the angles at all? I don't, so I know I'm not going to go that direction, all right? So what do we do now? Now, here's the tricky part. The givens, that's piece of cake, right? That's real simple. What about this? Can I just say that GL and KL are equal to each other right now? No, I had to know something before that, didn't I? All right? I had to know some evidence, right? What was my evidence? My evidence was that L is the midpoint. So I have to write that down. So L, oops, let's go back to white because I'll stay color coordinated here. Okay, so L is the midpoint, I'll just shorten midpoint to MP, of line segment GK. Now how do I know that L is the midpoint of GK? It's given, so I could put given again if I wanted to. All right? Now that in and of itself didn't say that I've got another side there. I have to make that statement though. So if L is the midpoint of GK, what can I conclude then? That GL is equal to KL. You could say LK if you want, but I kind of like to go G to L, then K to L. Is that all right? So I'm going to go GL is congruent, put line segment, to KL. Now, here's the big one. Why is that true? Good, and we talked about that a little earlier. So it's the definition of the midpoint. Does that make sense to you? So you have to give the given first, Because we can't just jump in and say GL is equal to KL. You got to write down all your statements, okay? So you have to say that L is the midpoint first. Since we know L is the midpoint, what do we know in our head, or even flipping in the book and looking, what do we know about midpoint? A midpoint divides, or it splits or divides a segment into two equal segments, okay? So if you go back and look at that word midpoint, that's basically what it will tell you, right? That it divides into two equal segments. So what did we just find right there? GL and KL. What can we put after that? We could put our third side, couldn't we? And what I like about doing this is I can just look down my statements and see side, side, side. Is that enough? Is that enough information to say my triangles are congruent? Absolutely. I don't have to show all three sides and all three angles now, do I? I have that theorem that says that if I just show all three sides, actually I think it's a postulate, isn't it? Is that a postulate? Yeah. That that's exactly what we're going to do. I'm going to do that right now. Yep, that's my next step. So now I've got side, side, side. Now what can I say about my two triangles? Now I can say they're congruent. So let's see, what do they call them? GHL. And notice how they name this thing.
Is this still in the chart or not?
Yeah, it's still in the chart. It's still part of my proof. This is the last step of my proof. So GHL is congruent. Now watch what I did. If I went G to H to L, what do I have to do over here? I have to go K to J to L. Do you see that? Because they match up. Look at the G and the K. How do I know that they match up? Look what side they're opposite. See how G is opposite the side with the three arcs, or the three tick marks? And what's opposite the side with the three tick marks over there? The K. Does that make sense? So the G and the K match up. Look at the H and the J. Do they match up? Yeah, because they're opposite the two marks. Do you see it? What about this angle right here? Yep, this is opposite the 1. This is opposite the 1. So they match up. Make sense? So GHL has got to be congruent to KJL. Because we flipped it. Yeah, it's like a mirror image. Okay, we took this and we flipped it over here like that. All right, now what's my reason? Yep, and all we have to do is just write side, side, side. You can just write side, 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 but sometimes I'll write postulate. Okay, just POST for postulate. If you just want to put SSS, that's fine. All right, but sometimes I put postulate. And that's your proof. That is your proof. That whole thing, not just the end of it, but the whole thing is your proof. Your answer, I guess if you want to call it that. We don't really call a proof an answer, but it's a series of steps, right, to show that those two triangles are congruent to each other.
But that's where you'll be checking.
That's it. I'll be checking, well, I won't check to see if it's right or wrong, but
I mean,
yeah.
That's how we determine whether we
Exactly. Like on a test or quiz, if I asked you to do a proof, then I'm looking for that whole entire thing. Now, there's a couple things that could change. Look, the GH and KJ, that doesn't have to go first. You could have put L as the midpoint first if you wanted to, right? What's one thing that you definitely could not put first? The last thing, right. You can't say that the triangles are congruent right at the beginning, can you? You got to go through those series of steps in order to say that. Here's another thing. You cannot put GL is equal to KL before you say that L is the midpoint. Does that make sense? You got to say L is the midpoint first before you say that GL and KL are equal. Okay? So there are certain things that, have to stay in a certain order, but you have a little bit of flexibility. I mean, these two didn't have to go in the same order. Actually, the L is the midpoint thing could have gone way up here. All right? It doesn't, that kind of stuff doesn't matter. But this definitely has to go last. The L is the midpoint of GK has to go before GL equals KL. Everybody got that? And all this stuff up here has to go before the triangles are congruent. So you do have a little bit of flexibility with this. And that's your first proof. What do you think?
I don't think they're that far.
Nope. QED. It's weird. Again, I don't know any Latin at all, but I think it's like, I heard somebody tell me it was like quid est demonstrantem or something like that, which means as was demonstrated. So, you know how on the end of some movies they put the end? Yeah. It's kind of like a proof equivalent to the end. So all right? You don't have to. You don't have to. I had a professor in college that did this all the time, and I just thought that was kind of funny. But look it up on whatchamacallit, Google, and see what they say about it. And QED, I don't know. It's like when you're all done, you're like, it's like putting a bow, right? Wrapping a bow on a present kind of thing. That's the QED. You don't have to do that. It's just kind of silly. But there it is. Just so that you know. Because if somebody else says QED, then you'll say, yeah, I know what you're talking about. Then you act real smart. Okay, right. All right. What do you think of that? Let's do another one. These are pretty good, aren't they? Let's do another one. It'll be a little.
Yeah, because sometimes.
Let's do another proof. It's gonna be basically proofs. I think all these things I'm giving you are, for the most part, proofs.
So we won't have any other.
I don't know. I said basically most of them. I don't know. I didn't look at every problem. Let's do another one. Okay, here we go. There's your picture. Let's write the given and then what we're trying to prove. So here's the given. I'll underline it, and I'll put all the given underneath it here. Okay, it says triangle QRS. Triangle QRS is isosceles. Isosceles. Yes, I want you to write out the given, what you want to prove. I want you to draw the picture, and I want you to write out the chart. Everything that I'm writing here is what I want on the proof. And then it's isosceles, and it tells you what sides are equal to each other since it's isosceles. They say that QR is congruent to SR. And we'll mark it after we've written all this stuff down. Then it says RT bisects. Remember what RT means? I mean, sorry, not RT, but remember what bisect means? Yeah, it cuts it. Let's not say in the half. Let's say like a midpoint. We don't say it cuts it in half. It splits it into what? 2 equal. In this case, you are bisecting a segment. You're right, Drew. It is segments. I was thinking of bisecting an angle at point T. All right. So that's all they tell you. Let's write the prove over here. Usually I wouldn't have them like real close to this picture, but I'm just trying to keep everything close to the picture so we can see all the stuff. And we're trying to prove that triangle QRT is congruent to triangle SRT. All right. We're ready to go. Stick with the red marking up the triangle, okay? It says triangle QRS. Let's find it. QRS. That's the whole big triangle, right? And it says QR and SR are equal to each other. That's easy. Boom, boom. This is the fun part, isn't it? Marking up the picture. I like doing that part. And then it says QR and SR. We already did that. QR and SR are equal. What else does it say? It says RT bisects QS. Here's RT. It's actually a ray, isn't it? But that's all right. You can have a line segment bisect it. So RT bisects QS at point T. Hey, we've already dealt with that before, haven't we? All right. So what can I say then after that? Right. Good. QT. I'll call it ST though, because probably the Q and the S go together, don't they? Because look, S is opposite this one mark, and then Q is opposite this one mark. So Q and S would be equal. So if I say QT, I'll say what? ST. So the Q and the S go together. All right? QT? Yes. All right. Is that enough right there? Now let's think about, before we do anything else, before we draw the, the 2 columns and all that kind of stuff, I always like to sit back, look at it, and try to do the proof in my head, right, before I actually start writing stuff down. So let's take a look at this. Can I use side, side, side? I don't think I can go side, angle, side, because I don't know anything about any angles, do I? Yeah, technically I do, tell you the truth. I don't know if we've done that theorem, though. I'll have to look to see if we've covered that theorem.
Because RT is the same.
Exactly right. You got it. Exactly right. That's good observation. Side, side, side? If I have 3 sides of one triangle equaling 3 sides of another triangle, then the triangles are congruent. But right now I only have 2. I only have this one and this one, and I got this one and this one. But, exactly right. Look at RT. RT is part of this triangle here, and RT is part of this triangle right here, isn't it? So even though it's the same segment, it's still equal to each other, isn't it? Equal to itself, really, isn't it? And we have a reason for this. Okay, when you have something equal to itself, like if A was equal to A, I'm just going to use that in general. I don't know if you remember this, but you probably did this back in Algebra 1, pre-algebra. Remember all these properties like associative property and distributive property and commutative property? Do you remember the one where you had one where it was equal to itself, and you might have blown it off? You're thinking, when are we going to use that? This is it, right here. Okay, we've hit the day where we actually use this thing. And anybody remember what it's called? Reflexive. It's the reflexive. It reflects, yeah. It's like a mirror, seeing the same thing in the mirror, right? It's kind of like reflection. So when you see something that's equal to itself, so what's equal to itself here? RT. Yeah, TR, it doesn't matter what you call it. You could call it TRRT. It doesn't make any difference. Okay, so RT on this triangle is equal to RT on this triangle. And what would be my reason for saying something that's equal to itself? Reflexive property. Okay, you may want to start keeping a list of these little things. Okay, definitions, right? Definition of bisector, definition of midpoint, definition of all this other kind of thing. We'll do more and more, and it'll all start building up. But right now, reflexive property, that's one of the most fun ones you can use because it's really simple to see. Now we're running short on time, so let's pop this out real quick, okay? I'm just going to do my statement and reasons thing. And let's go, I'll keep it red. And I'll just put S and R for statements and reasons, okay? So what's the first thing we're going to do? Do the given, right? So all I got to do, I don't really have to say it's isosceles. All I got to do is say that QR is equal to SR. And what's the reason? It's given. Okay, and that's one of my what? That's one of my sides, isn't it? Okay, what's the other thing they told us? That RT bisects thing, right? So I got to come up here. I got to figure out why this and this are equal. I can't just say QT equals ST right away. Right, because we only knew that because this thing bisected. So I got to write down RT bisects QS. And I don't have to say it I don't have to say it point T. I can just say that. Is that all right? What's my reason for that? Bisects QS, and that's given as well. Now, I definitely would. Yep, since we put that down right there, since we said T is since RT is bisecting this, what is it? What do you do when you bisect something? You split it up into what? Two equal parts. And what allows you to say that? That's right. So I can say that QT is equal or congruent to ST. And that's because the definition, we'll call it segment bisector, because we bisected a segment, didn't we? So I want to be a little bit more specific instead of just saying definition of bisector, because sometimes you might bisect an angle. So you would say definition of what? Angle bisector, right? So what is that right there? That's one of our other sides. How do we get that third side?
You would say TR is equal to TR.
Yeah. Yep. So TR equals TR. All right. That's kind of weird, isn't it? Something equals itself. But it makes sense, though, doesn't it? Because it's the same on both triangles. So TR equals TR because of reflexive property. And that's a nice, easy one. Because we have to have that third side. You got to show why that third side. And this is how we mark it. Watch this. This is how we mark it on our picture. Just like this. Just need 3 because there's only one line there, isn't there? So we put 3. So look, I've got a side, side, side. We're almost done. What is it? Triangle, blah, 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 equals triangle, blah, 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 because of what? Side, side, side. And then you're done. So you write what? QED. Boom. All right. Do you know what the homework is or not? It's the one from Thursday. Okay, it's the one from Thursday. Let's write it down. I'm writing it. Okay, so it's pages 267 to 269. All right, watch. It's spread out a little bit. It's 5 and 6. It's 12, 13, 14, and 15. I'll tell you what. Stop right there. I was going to give you 24 and 25. That's good enough. All right? So just do that. Well, we'll do them tomorrow. We'll do those on Monday in class, 24 and 25. Okay? That's it. Enjoy your weekend.